So in the previous slide, I asked you how you would calculate the instantaneous speed, or the speed at one specific point in time of on a curve. So I'm going to show you how to do this with this curve of y equals x squared. So again, this is a distance time graph with time on the bottom and distance on the y-axis. And we can imagine this is the distance traveled by this quad bike as it goes along in time. So I'm going to start off using our gradient formula again to solve this problem of what is the speed of at exactly 4 seconds. So in the previous question, we were asked what is the average speed between 10 seconds, 15 seconds, but in this one, we're being asked what is the speed at exactly 4 seconds. So it's going to be a similar process, but it's going to be slightly different. So we'll start off with m equals y2 minus y1 over x2 minus x1, where y equals x squared. So we'll take our first point as at 4. So x1 equals 4 and y1 equals just the square of 4, so that is 16. And then we'll start off with our y2. So for the first y2, we're going to choose 5. So we're going to go y2, x2 equals 5. So y2 equals 25, because that's just the square of 5. So we'll plug this into our formula. So that equals y2, 25, minus y1, 16, all over x2, 5, minus x1, 4. So that gives us a gradient of 9 meters. The 25 minus 16, that's 9, over 5 minus 4, that's 1. So that just gives us a gradient of 9. And this is looking for speed, so it's 9 meters per second. Okay, so the point I'm trying to say here is what would happen if we made the distance between these 2 points slightly smaller? Would it change this value at all? Well, let's just have a look. So instead of taking our x2 point as 5, why don't we take it as 4.5? Just 4.5. 5 just there. So how would that change the gradient? Well, let's just have a look. So our new y2 is 4.5 squared minus 4 squared, and our x is 4.5 minus 4. So 4.5 squared is 20.25 minus 16 from before, and then you have 4.5 minus 4, which is just 0.5. So what does this equal out as? So you take these two away from each other and you get 4.25 all over 0.5. So something divided by 0.5 is just the same as doubling it. And then that gives you a final answer of 8.5 meters per second. So you can see from when we've decreased this distance between these 2 points from 1 to 0.5, we can also see that our gradient, or our speed, has gotten smaller. So it's got more accurate, you can see, because this is actually closer to the time we're looking at. 4.5 is closer to 4 seconds, so it's going to give us a more accurate idea of what the speed is at 4 seconds. So I won't go through and do the math for every single point, but I've got a graph to try and help explain this. So this is just a graph of average speed against the time difference between the 2 points. So here the time difference was 1 between 1 and 5, and here the time difference was 0.5 between these 2 points. So here is a difference of 1 second, and then that's what we just calculated as 9. And then if we decrease the difference between 4 and 5 to 0.5 seconds, we see, as we just calculated there, it goes to 8.5, so it's getting smaller. What if we decrease it again to only 0.25 seconds between the two of those? You can see it gets even smaller, but it doesn't get smaller by quite as much. And then you keep going to 0.1 seconds, then 0.01 seconds, then 0.01 seconds. We can start to see that it's actually going to a constant, that even as you decrease the time difference more and more and more, it just kind of leads to a single value. And this is what will happen. This is the idea behind differentiation. You know, we're going to, if you just make this distance here so small, you know, as it approaches 0, it's actually going to hit a constant value. That's just, no matter how much smaller I get, it's not going to change much from 8. It's going to pretty much be that forever. So I hope that kind of gives you an idea of what we're trying to do with differentiation. We're trying to decrease the measurement between these 2 points to almost 0. So it's basically just 1 point. So we're just evaluating at this point. Okay. Thank you very much. I hope that makes things a bit clearer. Cheers.